Does your version control system have a read-only death grip on your files? Or perhaps you're not even using a version control system and you're just exploring your options before your hard drive crashes. If so, Git might be the answer. In my course, Get Going Fast, I provide a 1-hour crash course that walks you through the key concepts all the way to working with remote repositories on GitHub. I have designed this course with the busy professional in mind. I breeze through theory and academics so we can dive right into the action. Special text lectures with all commands complement the video demos along the way, which are reinforced by 4 quizzes. All I ask is just about an hour of your time, and I will show you everything you need to know about Git to productively start your journey. Let's cover the key concepts that you'll need to know for this course. Git is a distributed and decentralized source control system. However, it can be centralized, it just doesn't force you to be centralized. Effectively, most of our operations are going to be local. The only time we need a network connection is when we're pushing our changes up to the remote repositories. In Git, we think in terms of version snapshots, not versioning specific files or folders. This is a pretty big departure from other version control systems. The Git repository contains all the files, the history, configuration, all these things that are managed by Git. A commit is a group of saved changes to the Git repository. This impacts history and is uniquely identified by a SHA-1 hash. Branches can be thought of as a timeline with commits. By default, the master branch is our main primary branch that we work with. In this course, we will be doing all of our work on our master branch. Head is a pointer to the last commit on the current branch. Remote is simply a reference or a pointer to a related repository somewhere that's not local. That could be within our own network, within our enterprise, or somewhere out on the internet. Some examples of places that might be hosting remote repositories would include GitHub, GitLab, Bitbucket, and others. There are 2 ways to start a Git workflow. One is local and one is starting remote. So for starting local, we're going to initialize our current working directory. And on the GitHub site, you can go ahead and set up your GitHub repository. We're going to do some type of work here. So either editing files or creating new files in our working directory. Then we're going to stage our changes using the git add command. And then we're going to commit our changes that are in the staging area using commit. Once we're ready to collaborate with others, we'll push our changes up to our remote repository on GitHub. And to see the benefit of everyone else's contributions, we'll do a pull to pull in all our changes back to our local Git repository. This workflow looks slightly different if we were to start remote. So starting remote means we would go out to GitHub and set up our GitHub repository and then do a clone to create a new repository on our local system. Then we would do our work, add to staging area, and commit to our Git repository just like before. And when we're ready, we'll do our push and then pull back. And then when we're ready, we'll push our changes back up to GitHub and pull down any changes that may have occurred. Moving forward, anytime you want to begin new work, you need to pull down any changes that may have occurred while you were away. And then we'll work through the same steps that we did before, where we work on our changes, add to the staging area, and then commit to our Git repository before finally pushing our changes back up to GitHub. In this course, we're going to set up Git on Windows and the Mac. For Windows, go to git-scm.com and download Git for Windows. We'll be going through the installer and accepting most of its defaults. On the Mac, you actually have several options available. One way is if you already have Xcode installed, I'd recommend just using the Xcode command line tools. If you don't have Xcode installed, there's not really a compelling reason to install Xcode since it's a 5 gig download. Instead, you can also go to git-scm.com and download Git for Mac. Or you can use one of the other options like Homebrew or MacPorts. Alright, it's time to dive in. And my demonstrations will be on the Mac, but all the Git commands will be the same between the Mac and Windows. So if you're on Windows, once Git for Windows is installed, just fire up Git bash and all the commands will be the same. The exception to that will be when I invoke a text editor. In my case, I'll be using TextMate 2. So I'll be issuing the mate command from the command line to fire up TextMate. If you're on Windows, Git bash will fire up Notepad if you just type Notepad in the name of the file. Optionally, you could use something like Notepad++ and make sure it's on the system path. And then following each demo lecture, I'll have a command reference lecture so that you can have a review of all the commands that I use throughout this course. In this video, we're going to install Git for Windows. There are actually several ways to install Git on Windows. We're going to use a project called Git for Windows that provides us the most up-to-date version available for the Windows platform. This project is an improvement over the older recommendation of using the git-scm.com version of Git for Windows. As of the recording of this video, Git for Windows is still in preview. However, it is very stable, and for our purposes will be just fine. Either way, I recommend downloading and installing the latest version of Git for Windows. Let's start off by invoking our browser, in this case Google Chrome, then go to git, that's git, -for-windows.github.io. Once that page loads, click on the download button on the home page. This brings us to a page listing all the available downloads for the Git for Windows installer. You can see here that we have both 32-bit and 64-bit versions of the installer executable. Since I'm running a 64-bit version of Windows, I'm going to choose the 64-bit version of Git for Windows. Choose the version of Git for Windows that best matches your operating system. Now I'm going to click on the link for the Git installer for my platform. That will begin the download process for the Git installer. Once the installer has finished downloading, go down and click on Open. That will run the installer directly from the current location. If you are prompted about a security warning, just click on Run. Windows may also prompt you to make sure that you want to install this program. Click on Yes. Once the Git Setup Wizard starts, on the first page, click on Next. The second page has the license agreement. Again, click on Next to agree to the license agreement. The next page is select your destination. This is the location that Git will be installed on your system. For me, this location is perfectly fine, so now I will click on Next. On the Select Components page, I would like the Git Bash icon on the Quick Launch or taskbar, as well as on the desktop. To get both of those icons, I will check Additional Icons, which also checks in the Quick Launch as well as on the desktop. Then click on Next. This is the folder on the Start menu that Git will be installed. Since this is fine, I will continue by clicking on Next. This page dictates what parts of Git and Git Bash are installed. Although we will only be using Git Bash as part of this course, I recommend selecting the middle option. This will install Git Bash as well as integration with the Windows command prompt. In doing so, no real major changes are being made to my system, so it is both flexible and fairly safe. After you've made your choice, click on the Next button to continue. This screen is regarding how to treat line endings. On Windows, text files normally end with a different style line ending than corresponding text files on Linux or the Mac operating system. Which option you choose will greatly depend on whether or not you're going to be doing any cross-platform development. I prefer using the middle option, which is to check out as is, that is, don't change anything, but then commit Unix style. That means when I use Git to commit, the file endings for my text files will automatically be converted to a Unix style line ending. Since I bounce around between Windows, Linux, and the Mac operating system, the middle option makes the most sense for me. If you do all your development on Windows, and that goes for any team members sharing the same Git repositories, then the last option, commit as is will be the option you'll want to select. Again, I'm sticking with the middle option, and if I want to later, this can be changed. Once we've made our selection, click on Next. Regarding the terminal emulator to use, I'm going to stick with the top option, which is a minimal terminal emulator that runs the bash shell environment. Once you've made your selection, click on Next. This page, Enable File System Caching, is experimental, and I recommend leaving it unchecked for now. Click on Next, and now we are installing Git for Windows. Once the installation process has completed, on the final page, we can uncheck the View the README. Then click on the Finish button. Now, let's close Google Chrome. While we're here, let's verify that Git for Windows with the icon on our desktop. Looks like it's there. So now, let's double-click on Git Bash to fire up Git Bash for the first time. Now that we've done that, let's verify that Git is installed. Type Git, that's Git, space, version. Once you've done that, press the Enter key. Git should respond with the version of Git that's installed. To close Git Bash, we can click on the Close button that's part of the window, or we can type the command Exit. Welcome. In this video, we're going to install Git on the Mac. Open up your terminal program and simply type Git version, then press Enter. If you get this response, that means Git is not installed. However, with newer versions of the Mac operating system, we will be automatically prompted to install Git using the developer command line tools. When this prompt comes up, you have the option of getting Xcode, which will include Git, dismiss this dialog entirely, which means not to install Git, or to install, which will install Git using the command line tools. Click on Install. On the license agreement, click on Agree. This will begin the download and installation process. Once the installation process is finished, click on Done. Great. To make sure we have a clean terminal session, let's quit out of terminal, Command Q, and fire it back up. Now type Git version, then press Enter. If our installation was successful, Git will respond with the version number that's been installed. And in this particular case, we have in parenthesis the qualifier that it's an Apple version of Git. Welcome back. I just went over how to install Git on both Windows and a Mac. So now we should be able to invoke terminal or Git Bash for Windows and start using Git. One of the first commands anyone should learn how to do is how to get help. And with Git, it's pretty straightforward. So you just type Git help and then press Enter. And Git help actually returns back a list of different help options. In this case, it's Git help and then the name of the command. One of the next commands we'll be using is actually the config command. So I will follow the recommendation and specify Git help config. Now I'm going to press Enter. And this is one area that the Mac and Windows differ a little bit. On the Mac, I have a less-based man-style help page. On Windows, Git Bash will actually invoke your default browser and take you to a page with similar information. So back here on the Mac, I can scroll up and down to review the different options available to me with the Git config command. And when I'm satisfied with whatever I need to learn here, I can just press Q to exit. So that returns me back to the prompt. Well, I'm back in my terminal, ready to get going with Git. And before we can get started, we need to configure Git with some basic information. The bare minimum we need to tell Git about is our name and our email address. So we're going to issue some commands to configure Git with our name and email address. Before I do that, I'm going to tell you where we're at. Within our bash environment, we can issue the pwd command. That's present working directory. And this confirms that I'm simply in my user directory. So these commands can be issued from really any place in your system. We're going to be issuing global commands. So I'm going to type git config -- global. That's to configure at the global or user level. These configuration settings will be independent of any repository we might be using in the future. And then my first setting I'm going to use is user.name. And then I'm going to put a space, and then in double quotes, I'll put my name. I'm going to press Enter. For Git, at least with the config command, no news is good news. I'm going to type in a similar command for our email address. So git config -- global space user dot email space double quotes, and then I'm going to type in my email address. Now I'm going to press enter, and again, no news is good news. We can confirm that Git is aware of our settings by typing git config space -- global space -- list. And Git echoes out what it knows about our current global configuration settings. Now, what Git is actually doing behind the scenes, it has created a simple text file within our user directory that is called .git config. In fact, if I echo that out by using the cat command that simply just prints out the contents of a file, you can see the format that Git uses. So cat, I'm going to use the tilde to specify my home directory /.git config. So you can see this is how Git tracks global configuration settings. Alright, welcome back. Well, I'm back in my terminal, and now that we have explored how to get help with Git and that we've done the bare minimum configuration settings with Git, we can finally start working with the Git source control with a project. Starting out, there's a couple of approaches we can take. We can either initialize an existing project with Git, or we can start from scratch. So the first way I'm going to show you is just simply starting from scratch. So I'm going to use my pwd command to kind of show you where I'm at. So I'm in my home directory, and I have a projects folder that I like to keep all my different work in. So I'm going to change directory, that's what cd means, into projects. So if I do a pwd, I'm in the projects folder under my user account. So this is the location that I want to create my projects. And to do so with Git, I'm going to use the git's init command. So I'm going to type git init, and then the name of the project that I want to create. So I'm going to say git-demo. So what Git has done is it's created a subfolder named after the project that I just gave it. So if I just do an ls, which is the same as dir under Windows, you can see that I have a git-demo directory. Now I'm going to change directory into that, git-demo, and now I'm in a working folder of my Git repository. If I do a ls, you can see there's no files here because we just initialized it. This is a fresh project. However, it's not truly empty. If I do an ls-a, it will show me that I have a .git directory within this folder. The .git directory is actually where Git manages all the different files relevant to the Git source control. Without that .git folder, you don't have a Git repository. However, most of the time, the .files or the .folders are hidden from our normal view, although we can always use the -a command to see them when we need to. In this video, I'm going to show you how to initialize a Git repository using an existing project. And to do so, I've gone out to the initializer website so that I could create a simple project to get started with. So I already went ahead and set up my configuration, selected the options that I wanted, and clicked download, which downloaded into my download stack. Then I copied all the files they provided into my project's website directory. So I type pwd, I'm currently in my user directory. If I go into cd projects, this is where I put all my projects that I work on. And I create a folder called website, which is the starter project that I got from Initializer. If I do an ls, you can see all the files that are part of this project, and it's currently not being managed by Git. In order to put this project under Git's control, I'm going to use Git's init command directly from within this folder. So I'm going to type git init, and that's it, and then press enter. Now Git tells me that it initialized a repository, and like before, it created a .git folder that actually contains the Git repository files and folders. You'll also notice that my prompt changed, and you can see that my prompt changed to point out the fact that I'm on the master branch of the Git repository. To see the .git folder within our project folder, we'll just do an ls-a, and you can see it listed over here. So I'm back to my Git demo project, and if I do a pwd, you can see exactly where I'm at in my system. I'm in a project subfolder and a folder called Git demo after my project name. So now we're ready to actually start editing some files for the first time. And if I do an ls, which just lists out all the files I have in my project, you can see that I don't have any. So I'm going to use TextMate 2, which is a freely available text editor for the Mac, to create and edit my files. On Windows, you can just use Notepad or Notepad++ or your editor of choice. So let's start off by creating a README file. So I'm going to type mate, which is the command line way of invoking TextMate, and I'm going to use all caps for README. It's just a convention, and .md. I want to use Markdown as my format, which is really just an offshoot off of a plain text file. I'm going to press enter, and it launches TextMate for me. So I'm going to start off with a first level heading. So I start with a single hash, and TextMate is smart enough to realize that I have a .md file, which means I'm using Markdown, so it will adjust accordingly. So I'm going to say demo git repository, and after that maybe I'll put some verbiage. This will be like a paragraph. So I put a couple lines in here. Now I'm going to save this document by doing Command S, and I'm going to close this program using Command W. So now I'm back to the command line. If I do an ls, you can see that I have the readme.md file in my folder. However, Git is not really aware of it, or it's aware of it, but it's not really tracking it. So the way we can confirm that Git is not really tracking this file is to use the git status command. So I'm going to type git status, and it's going to tell us several pieces of information. One is that we're on branch master. Whenever you create a new repository, you will automatically get a branch called master. This is the default branch. Theoretically, you could change this, but I would highly recommend against it. Just always keep your main branch called master. After that, it tells us we have an initial commit. What it's really telling us is we're building up to our initial commit. We haven't actually done a commit yet. And that it sees one untracked file. And all that just means is Git is just not actively tracking it. So currently where we're at with our Git workflow is we're editing files or creating new files within our workspace. We haven't added them to the staging area, so Git isn't tracking them, and we certainly haven't committed those changes yet. So the next step is to move forward and add this new file, the readme.md, to the Git staging area, also known as the Git index. And to do that, we're going to use the git add command. So you type git add and the name of the file. So readme.md. You press enter. So now what we do is a git status again, and it should say something different. So git status, and this time it says changes to be committed. That's just Git's way of saying these are the changes that are currently in the Git staging area or the index, waiting to be committed. So that's where we are with our Git workflow, is we're in the staging area. And we also see that Git is telling us that we have a new file, that this isn't something that it's tracked before. So to move forward, we need to use Git's commit command. We don't specify files, we just commit. So if we type git commit, and I like using the -m command for simple messages to sort of add the commit message on the command line. So I'm going to say initial commit. And now I'm going to press enter, and we have done our first commit. Now I'm going to clear to give myself some more space. So now if we do a git status, it tells us that, again, we're on the master branch and that there is nothing to commit and we have a working directory that's clean. Basically, we're back to the same point we were before we made changes to our working directory. So now that our working directory is back to a clean state, we're free to make additional changes, create new files, edit the existing files, and keep working with Git. So let's continue on making modifications to our README file within our Git demo repository. So again, I'll verify where I'm at. So pwd shows that I'm in our Git demo repository folder. And if I do a git status, you can see that I have a clean working directory. So I want to add some more text to our README file. So now I'm going to fire up TextMate, specifying the README file. Press enter. So now our README file is open and ready for editing. So now I'm going to hit return a couple times, and maybe we'll do a second level heading. So that would be 2 hashes. And for this heading, I'll just tell people we're using some Ipsum. So some Ipsum below, and then I stole some text off of the hipster Ipsum website. So now I'm just going to paste that in. It really doesn't matter. You can just type in whatever you want here. It's just text. So now I'm going to save this file. Now I'm going to close, and we're back to the command line. So if I do a git status, you can see that now Git sees that we have a modified file. This is how git status tells you that it sees a non-staged file out there that it is tracking. So any files you've added to Git, Git will be tracking until they're removed from Git. So Git can see that we have modified the previous file of the readme.md. Now I need to move through the same process I did before. So I'm going to use the git add command. And this sounds counterintuitive that you would add a file that already exists, but the way I like to look at it is that we're adding the new changes into the staging area. So git add, and then readme.md. If I do git status again, it sees that our modified file is in the to be committed state, which is git status's way of saying it's being staged. And to continue forward, we need to commit our change. So we can type git commit. And again, I'm going to do the -m to do my inline commit message. So adding some Ipsum. Let me clear to get some space. So now if I do a git status, we're back to a clean working directory. So I'm going to go through the process one last time, but this time I want to show a shortcut along the way. So I'm going to edit the file again, go to the end, and I'm going to paste in even some more Ipsum. I'm going to save, and now close. So now that I'm back to the terminal, if I do git status, you do have an option to take a shortcut if you have modified files. That is, a file that Git is already tracking. You can simply add and commit in one step. So that's what I'm going to do. So I'm going to go directly to the git commit command. So git commit, and I'm going to specify -a. That's going to add my modified file to the staging area and then commit immediately after that. I'm then also going to put my M switch in there so that I can do my commit message. And in quotes, I'm going to say adding more Ipsum. And it just added and committed in one step. And so now if I do a git status, you can see I'm back to a clean working directory. Let's work through the working directory changes, adding to staging area, and finally committing workflow a few more times. So again, if I do pwd, you can see that I'm back in the Git demo project. If I do git status, I have a clean working directory. So I'm going to clear. Let's add a new file. So let's say for this project, I want to create a website. So I'm going to use mate to create a web page. So I'm going to type mate, and I'm going to call it index.html. Now I'm just going to paste in some boilerplate type of HTML. You can find this HTML markup pretty much anywhere online, but I will be including all the source from this course on my GitHub account. Okay, now that I've inserted this markup, I'm going to hit save. So that's Command S, and now I'm going to close mate. So now that I'm back, if I do git status, you can see that I have an untracked file. That means Git isn't actively managing it yet. So now I'm going to add it. If I do git status, see we have a new file. And at the same time, I want to do a few more changes to our README file. So mate, README, and maybe I want to back out some of this Ipsum down here. Maybe I really don't want to do that. Maybe I want to say website contents. And maybe I'll just list out the different files that I plan to have in my website. So I'm going to save and close. Git status. In fact, let me clear and do it again. Git status. So what you can see here is that Git will show you the newly modified files as well as anything that's in the staging area with the git status command. So now I can move the modified README file up into the staging area by doing the git add command again. Now if we do a git status, you can see both files are in the to be committed state, which is the staging area. And if we just do git commit -m, provide a useful commit message. So you can see now that we've committed those changes, we didn't have to specify any files. It just took everything that was in the staging area and committed it. Let's keep moving forward. Let's make a few more changes. So I'm going to use mate again, and we'll make a few README file changes. Let's add an introductory paragraph before our list. Here are the files in the website. Save, close. Let's edit our index page again. Maybe I'll just change this to home page. Save and close. So now I have two files that I have modified in my working directory that I haven't staged or committed yet. So if I do a git status, Git shows us that we have two files that have been modified. Up until this point, I've been specifying the specific file with the git add command. What I can do in this case is, since I have multiple files, I can actually use some shortcuts. So I'm going to type git add, and then if I just use a period instead of the file name, Git will recursively add any new or newly modified files to the Git staging area or Git index. So now if we type git status, it says these changes are to be committed. So these modified files are in the Git staging area. Again, I'll follow through and commit what I have. And now I have committed my changes. So now we should be fairly proficient in adding our files to the index and finally committing them. We're going to walk through this process one last time, but with a little bit of a twist at the end. We should be clean. So if I do a git status, I should have a clean working directory. If I do an ls, you can see we have a README and index page. So let's edit the README file one more time. Mate README. I'm going to add another heading. And now I'm going to paste in some more hipster ipsum. Now I'm going to save and close. So do a git status. We can see that newly modified file. Git add the README file. Git status. And it sees that it's been modified and that it's to be committed. That is, it's in the Git staging area. But at this point, I really don't want boilerplate text. I'm ready to actually use a real README file. So I want to back out that ipsum lorem that I just put in there. So I'm going to follow the advice the git status command gives me. It tells me in order to unstage that I need to use the git reset command, specifying head and the file. So we're going to do that. We're going to type git reset head and then the file that we want to unstage. Now we press enter and that file has been unstaged. Let me clear to give myself some more room. Again, we're going to do the git status command so we can kind of see where we're at. So these are changes not staged for commit. And I want to show the contents of the file right now. Invoke mate again. Show that README file. So we have all the ipsum lorem down here. So all we did is we just backed it out of the Git staging area. Now what I want to do is discard my changes that are in my working directory. So I'm going to follow the advice. I'm going to use the git checkout command as described up here in my git status command. So I'm going to type git checkout -- and then the file name. So readme.md. I'm going to press enter. And again, with Git, usually no news is good news. However, I can verify what happened by opening mate up again. So mate and then my readme file. And now this time we can see that our readme file has returned to the way it was when we last committed to Git. So now I'm going to close mate, and we can just do another git status to sort of verify where we're at, and we are back to a clean working directory. At this point, we've made several commits to our Git repository, but we've been pretty much taking it for granted that the commits have been going in. So what we're going to do is use git's log command to actually display the history of the commits that are part of this repository. So I'm going to type git log, And now you can see all the commits that we have done thus far for this repository. And you can see that it's going in reverse chronological order. That is to say that the last commit that we made is at the top. And with the standard output of the git log, you can see that there's this long hash, that's a SHA-1 hash, that represents the unique identifier for our commit. Next, you can see the author name, which has been me, and my email address. So we set this up at the very beginning when we did our config commands, and the date that these commits were made. And indented a little bit, you can see our commit message. This is fine, but it's a little bit much for just seeing your history, especially once we have a lot of commits for a repository. So as it turns out, the git log command actually has lots of options. So if I type git help log, we can kind of see all the different options that we have at our disposal. So I've already set up a list of log options that I want to use. I type git log dash dash one line dash dash graph dash dash decorate dash dash color. And that gives us a much more compact view of our Git repository's history. So in a previous video, I covered how to back out changes from your working directory as well as the Git staging area. In this video, I'm going to cover how to back out changes that you've already committed. So before I get started, I need to do a little bit of setup to show how this is going to work. So as you can see, I'm in the Git demo project folder. So if I do a pwd, it shows exactly where I'm at on my operating system. If I do a git status, we have a clean working directory, which is what we need right now. And so what I'm going to do to show this example is I'm going to create an application log, maybe a debug log, that really doesn't belong in version control. So I'm going to type mate debug.log. I'm going to just write some text lines that would be in our log. So starting application. You get the point. So at this point, I'm going to save and close. So now if we do an ls, you can see that we have the debug log file in our directory structure. So if I do a git status, you can see it's in fact an untracked file at this point. I'm going to add. If I do git status, Git shows us that we have our new file. And now I'm going to do a git commit. So I've added the log file to our Git repository. Obviously, this isn't something you would want to do on purpose, but it might be something that would happen accidentally as you add files to the Git staging area and then inadvertently committed to the Git repository. So now I'm going to clear to give myself some more space to work. So if I do a git status, you can see we're back to a clean working directory. So that log file is already committed and it's part of the Git repository. But I really don't want that file to be there, so I can use git's rm command to remove that file. So I do git rm and then the file name. So debug.log, and Git responds back saying that it removed that debug log file. If I do an ls, you can see that Git has already deleted that file from our operating system. However, if I do a git status, it shows this in the to be committed state. That is, the fact that we did the delete of the file has been added to the Git staging area, but it has not been committed. So in order to make this change permanent and affect my Git repository, I need to go ahead and commit that deletion. To git commit -m removing log file. Let me clear again. And now I'm going to show you another way to delete files from Git. So I'm going to go through the same setup process I did before. So mate, I'm going to call it info.log. Add some text, save and close. You see the info.log file is here. So I just added the info log, git status. Now that we've set up for this second pass for deleting the file, I'm going to do this without using Git. So if we just do an ls, we can see the info.log file is there. So we can remove this file by just typing the rm command, which is what I'm going to do, or Finder, or in Windows, you would use the Windows Explorer. The idea is that you're going to remove this file outside of Git's knowledge. So I'm going to type rm info.log. So now if I do an ls, So the info.log file has been removed from the file system without Git's knowledge. So if I do a git status, so Git detects that info.log has been deleted, but has not been staged for the commit yet. So this is a working directory change. So just typing git add is not going to add the removed files or the deleted files to the staging area. That's not the current version of Git's default behavior at the moment. Now in Git 2.0, this behavior will change. But for now, we need to pass in a -u to our git add command. So now I'm going to type git add -u. So now if I do a git status, Git tells me these changes are to be committed. So it picked up on the fact that we had our deleted file and added that deletion to our staging environment. So to commit this, I can continue forward by typing git commit -m removing info.log. And now the Git repository has reflected this file has been removed. All right, welcome back. We are in our Git demo project. And in this video, I'm going to show you how to move a file using Git. So if I do an ls, you can see that I have the readme.md file as well as the index.html file. Well, moving forward, I really don't want the index.html file to be part of my root folder for the project. Instead, I want to have a separate folder that will be the root of my website. So now I'm going to type mkdir for make directory, and we'll just call it web. This will be our root folder for our website, but it will be off of the main folder for our project. So now if I do an ls, you can see that we have the web directory. So like before, there are a couple ways we can do this. We can either do it with Git or without Git. So I'm going to use Git to actually move the file. So if I type git mv for move, and then my index.html file, so my source, and where I want it to go, so web. As with most things with Git, no news is good news. So I'm going to change directory into the web folder. And now you can see that I have an index.html file that is in this folder. pwd confirms this. I'm going to back out. I'm back to my root folder within Git demo project. And now if I do an ls, you can see the index.html file is not here. Now if I do a git status, Git tells me that this file has been renamed, and essentially we're renaming to another place on the file system. So you can see here that Git has staged the fact that the rename or move has occurred, but it has not committed it. So to take the next step, we need to do a git commit command. So git commit -m moving index.html file to web folder. Press enter, and now the rename is completed. If you were to rename or move your files outside of Git, you would simply use the -u parameter as part of the git add command. Now that we know how to add files to Git, let's learn how not to add the wrong files to Git. So I'm going to start off by creating a new file. I'm going to call it application.log. I'm going to add a few lines that might be log lines from an application that might be logging into this file. I'm going to save and close. So now if I do an ls, I can see that I have an application.log file in my project folder. And log files are generally files you don't want to have in version control. So if we do a git status, you can see that Git sees that there is an application.log file laying around in my folder. I don't want to accidentally add this file to source control, because then I'll have to remove it later. And those are just more steps I really don't want to do if I don't have to. Thankfully, Git provides an ability for us to exclude files that we don't want. It's called the .gitignore file. So if I type mate.gitignore, and the ignore file format is simply one pattern per line. And so a pattern could be the name of a folder. Like if you're using a Java project using Maven, then you might want to exclude the target directory. But in our case, we want to exclude any file that ends with log. So I'm going to do the *.log, and I'm going to save and close. Now if I go back to the command line, I can see if I do an ls, we have an application.log file still there. And if I do a git status, it only sees the .gitignore file. Now when I did the ls command, it didn't show me the .gitignore file. And that's because dot files and dot folders are kind of excluded by default. You're kind of hidden, if you will. So if I do an ls-a, then it will show me the .gitignore file. The .gitignore file is actually a file like any other file that's part of my project. So I need to check that in the version control. So if I do git add .gitignore, now if I do git status, you can see that we have our new file that's been staged. And now we need to finalize it by committing, adding ignore file. In this video, we're going to set up our SSH key so that we can use SSH authentication with GitHub once we set up our account. So if you're still in the Git demo repository, we're going to go back to our main user directory. So I'm going to type cd tilde, and that will take us back to our home directory. If I type pwd, you can see that I'm back in my root of my home directory. Now I'm going to see if I have an .ssh folder, which I don't. So I need to create the .ssh folder, which will house our SSH keys. So I'm going to type mkdir for making the .ssh directory, so .ssh, and now I'm going to change directory into that. So now I'm in my .ssh folder underneath my home directory. Now I'm going to issue a command to generate my SSH key. So SSH dash keygen, and pass the dash lowercase t space RSA, because we want to use the RSA type of key, dash capital C, and then space, and then in quotes, your email address. So I'm going to put my email address here. And now press enter. It's going to ask you where you want to save this key. The default will be fine, which will create a ID_RSA file. Then enter a passphrase. I'm going to use a passphrase. I highly recommend it. Once that's been saved, your SSH key has been created. If you do an ls-al, that will show you all your files that you have, even your hidden files in the current folder. And we can see we have two files here. We have an ID_RSA and an ID_RSA.pub. The .pub file is the public side of the key, and that is the contents that we will be pasting into GitHub once we make it over there. So what I need to do now is copy the contents of the ID_RSA.pub file. So I'm simply going to open it with a text editor. So I'm going to use mate in this case. And I'm just going to copy everything. So I can do a Command A and then Command C. Now I can close that file. Now we can go to GitHub. So go to github.com, and once the GitHub site loads, if you haven't signed up for GitHub yet, just go ahead and pick a username, fill in your email address, and create a password, and sign up for a GitHub account. It's free. They allow you to have unlimited public repositories. I already have an account, so I'm just going to go over here to sign in, and I'm going to use my username and password and sign in. Once you've signed in, you need to go to the account settings. Once you're at account settings, you need to go to SSH keys. Once you've done that, go over here and click on Add SSH Key. Give it a title. At this point, it doesn't matter what title you give it as long as you can remember it. And remember that SSH keys are tied to your computer. And now, let's paste in that key. Now, if the key was not in your clipboard, just use those steps we just went through to open it up in a text editor, select all, and copy it to your clipboard. And then come back to this web page and paste it in. Once it's been pasted in, hit Add Key. When this returns, you know that you've added your SSH key to GitHub. So now we're going to go back to our terminal, and we're going to use the SSH command to try to access GitHub. So I'm going to type SSH capital T, and now we're going to say git at github.com. And the first time you do this, your system's going to ask you if you're sure you want to establish a connection, because you haven't done this before. I'm going to say yes. What it did is it permanently added GitHub to my known host file, so I won't get that prompt again next time. And then it tried to connect to GitHub, and GitHub said, welcome, my user ID, and that I successfully authenticated. Then, of course, it pointed out the obvious to me, which is that GitHub does not provide shell access. You really don't have to worry about this. All we wanted is that you successfully authenticated. This is the piece that we're looking for. At this point, I'm just going to return back to my home directory. Welcome. In this lesson, I wanted to provide a quick update to this course regarding the default branch for Git and GitHub. The reason for this change is very political, and I'm not going to dive into that. I just want to help address the issue which is causing some errors in some lessons in this course, as well as some confusion. A while back, the Git community decided to migrate away from the term master as the default branch name. The main Git project has been taking a gradual approach by adding support for setting a default branch name, giving instructions on how to change a default branch in existing repos, and warning users of possible change in the future. This all started in Git version 2.28 and later. As of the production of this video, the default is still master, but the Git project is actively encouraging the use of other names as the default. This could change in an upcoming update. However, GitHub, the most common Git repository hosting provider, decided to make the change more suddenly. While GitHub has not changed the default branch on existing repositories, although it certainly could do that, they did set the default branch name to main for all new repositories. So, if you create a repository locally with the default branch name of master, and then attempt to push that to GitHub, you might encounter an error, especially if you continue to explicitly reference master as the target branch name. However, this default can be reverted back to master, which might be preferred in some cases. Okay, there are two approaches we can take. As just mentioned, we can simply reset GitHub's default branch name to master, at least until the end of this course. This approach will have the least impact on the rest of the course. Let's try that out. I'm going to head over to my computer, open my web browser, navigate to GitHub, and then log in. Once logged in, expand the options under your profile and choose Settings. Once on the Settings page, go to Repositories. Once there, for Repository Default Branch, replace main with master, and then click Update to save the change. Now, let's test this out. Return to the main page on GitHub, create a new repository, give your repository a unique name, an optional description, and add a README to it. Once we do that, GitHub should tell us the default branch name, which should be master for the repository. Click Create Repository to continue. GitHub will create the new repository with the default branch name as master, as we configured within settings. Now, the rest of the course should work without any changes. Once you're done with the course, you can optionally return to your settings page and reset the default repository branch name to main, or whatever your company's corporate standards are. The second approach would be to just embrace the change. In this case, you would simply leave the new default as main, and make the adjustments on your local side accordingly. First, we need to start off making sure our version of Git is at least 2.28 or later. If not, we need to update it before proceeding. In my case, my version of Git is out of date. Let me hop over to the official Git website and download the latest version. This is for Windows. On Mac, if using Apple Git, make sure you have the latest OS and related software updates installed. If running on Linux, use your system's package manager to update. Alright, although I can specify the default branch during the setup wizard, I prefer to show the current default behavior before making any changes. Okay, Now that I have reinstalled Git for Windows, let's try that again. Great. It looks like I have a new enough version of Git. Let's start by creating a new repo, just specifying the repo name. This will use the current default branch name. Once the repo has been created, let's go into that directory. Our prompt shows that we are on the master branch, which is the current default. We need to add at least one commit before we can change the branch name. So let's do that right quick. Okay, great. We have our first commit on this repo. So now we can change the default branch name with the following command: git space branch space -m space and then the name of the branch, main. The -m option tells Git to move or rename the current branch to the name we just specified, which is main. Okay, now that we have our local repository set up, and with the default branch changed to main, we can proceed to creating the repository on GitHub. I'm going to give it the same name, just to keep things easy. Provide an optional description, and I will make sure not to add any extra files during the creation process. If you did things correctly, you should end up on a page like this. Now, I'm just going to follow the instructions to add the remote reference to my local repository, copying and pasting the first command like so. Since we have already renamed our local default repository, there's no need to do the next line. That just leaves pushing the local repository to GitHub. Git push origin main. Instead of specifying master, I specify main instead. You'll need to make the same adjustments throughout the rest of the course if you go this route. Okay, it is actually possible to specify the default branch to start a repo on the local side, so let's do that too. Back in my projects folder, I will create a new Git repository, but this time I'll pass in the newly added -b flag to allow me to specify main as my default branch for this repository. Once done, I'll go into the repo, and we can see my prompt reflects main as the default branch. As part of the recent updates, Git added the ability to configure the default branch. Use this command: git config --global init.default branch with a capital B, space, and then the name of the branch you want to use. In my case, main. This will update our settings to use main as our default branch unless we specify something else explicitly. Let's double check to make sure the setting is configured. Git config --global --list. Now let's try it out. Again, back in the projects folder, I'm going to create a new repository using the same init command as before, only specifying the repo name. Now, if we go into our newly created repo, we should see our prompt is using main as the default branch for the repo. Okay, one last example. This should be pretty straightforward, but I want to cover it just the same. Go back to your web browser, create a new repository on GitHub. We're going to assume we're going to use the new default on GitHub. That is main. If you need to reset the default branch name back in settings, go ahead and do that first. This time, I will add the README file to the repo as I create it. Great. Now with the new repo created with our README file, let's clone the repo to our local system. Alright, back in the terminal and projects folder, git clone, and then paste in the git clone URL. Now, here we can go into the repo and see that it has the main branch. Let's edit the README file. Commit those changes, and then push those changes back to GitHub. The first time, I'll use the full command, specifying the remote name and the branch name. Git push origin main. Back in the browser, refresh the page to see our changes. Let's do that sequence once more. Edit the README file. Commit the changes, and now I'm going to push the changes using a shorter version of the push command, git push. I'll let Git assume the remote and branch name. I just wanted to make sure this still works as it should. Brilliant. Again, refresh the web page to see the changes. As course impacts go, the first option offers the least impact overall, once you change the default branch name in GitHub. However, the entire community is trying to move away from master as the default branch, so perhaps the second option is more forward-leaning. You'll just have to remember, whenever I say master, referring to the default branch, to replace that with main instead. Overall, I don't think this is a huge change, but it can be confusing if you follow every command exactly. I hope this video will clarify things until I have time to completely revise the entire course. Well, everything we've done up to this point has been local. While working with Git locally is perfectly okay, most of the time you're going to want to collaborate with others, and in order to do so, we'll probably need to use some sort of remotely hosted Git repository. That way it's fairly easy for others to join our project, and we can manage who has access and who doesn't. So we're going to create a remote repository on GitHub. So go ahead and go back to GitHub and log in with your account. And when you log in, you should be able to see a green New Repository button. Click on that, and we're going to call it Git Demo. And the repository name just has to be unique based on its owner. In the description, it's optional, but let's fill in something here anyway. We're going to have it as public, and I'm going to leave this unchecked. Since we already have content that we're going to be pushing up to our remote repository, I don't want to cause any unnecessary conflicts. So now I'm going to hit Create Repository. So on this quick setup page, I'm going to click on SSH. So now we're going to go down here where it says push from an existing repository, and I'm just going to copy this first command. And then I'm going to return back to my command prompt. So I'm going to do a git status first. Before I do anything with pushing to a remote repository, I want to make sure that I don't have anything pending out here. So I need to be back in a clean working directory state. So now we're going to paste in the command from the GitHub website, and now press enter. Now if we type git remote-v, we can see that origin is associated with this remote repository on GitHub. So this is our remote reference. And origin's just the convention we use for the main repository that we link up to on the remote side. We can have additional remote repositories, but origin's usually our first one, if you will. So now I'm going to push our changes up to populate the remote repository with all the changes we've made locally. So I'm going to type git push. So the first time we push to a remote repository, we need to use the -u parameter. This is going to establish an upstream link between our remote repository and our local repository with the master branch. Now I'm going to specify our remote repository origin, and we need to specify the branch. So we only have one branch, which is the default branch, which is named master. When we're done all that, just press enter. Alright, so let's look and see what happened here. So you can see that Git wrote all our information that we had locally to our new remote repository. And since we set up the -u parameter, our branch master is set to track the remote branch master from origin. So once we've done that, we don't have to specify the -u parameter anymore. We can do git push origin master. And since we just pushed, everything should be up to date, which it is. So now if I go back to our Git repository on GitHub, so now you can see the contents of our repository are now on GitHub. So we can go to our web directory, and we have our index.html file. We have our readme.md file. So if you notice carefully, GitHub automatically displays a file called readme.md in the current folder, which is one of the reasons why I like using Markdown as my readme format. So now returning to terminal, let's make some edits to our local repository and make sure they make it up to our remote repository. Let's go back into our web folder, and I'm going to edit our HTML page. I say homepage change to be pushed to GitHub. Hit save and close. Git status. We modified our index.html file. So now I'm going to use my shortcut, git commit-am, updating index page for GitHub. If I git status, now that my local repository is linked to my remote repository, the git status command will tell me that I'm one commit ahead of origin master. And origin master is just Git's way of referring to the remote repository's master branch. So we can see that in action. So if I go into web, do a reload, click on index.html, you can see that our change is not on GitHub yet. I go back up one, and I'm going to return back to the terminal. And I'm going to just follow a best practice here. I'm going to actually do a pull to fetch any changes that have changed and merge them into my repository before pushing my changes up to GitHub. So I'm going to say git pull origin master. So it goes out to my remote repository and it looks to see if anything has changed, and everything is up to date because there's no one else contributing to my repository. But I like to do this anyway just to show you what the best practice should be, because in all likelihood you would be working in conjunction with other developers or other people against the same repository, and you just want to avoid conflicts. So it's always the best practice to do a pull before you push changes up. So now I'm going to proceed with a git push origin master. And now you can see that we have successfully pushed our change up to the remote repository on the master branch. So now if I go back to GitHub, reload this page, you can see our commit message that's associated with the commit that we just did. And if I open it up, you can see our change here on GitHub.